All right, the next one here is the active-active architecture discussion for RGW. That's Yehuda. Yehuda, I see you. Do you want to turn on your camera and take it away?
I don't have a camera in here, but
This works too.
I can take it away. I can see my silhouette.
You're good to go.
All right. So yeah, the first one we're talking about is the active-active. First, what it means. Let's see what we have currently. The RGW multi-zone, multi-region stuff that we did for dumpling. Originally, what we designed was something like that. We first said we want to have regions in which each region would have data in it, and in each region you might have multiple zones, and each zone would replicate the other zones, basically used for disaster recovery. So you'd have a master zone within each region and secondary zones that will follow it. So you might have two regions, let's say US East, US West, and on US East you'd have two regions, 1 and 2, East 1 and East 2, and on West you'd have West 1 and West 2, and you'll need to provide a single zone that's going to be the master of all for the sake of metadata, because it's the one that's going to control all the metadata. You don't want to have split brain, so everything's metadata related is going to go through it. But then you can start creating buckets on the secondary region, for example, and the data is going to reside on the secondary. On the West one, and you can create buckets on the East one. And when you access data on the East zone, you're gonna go to the East zone. On East one, you're gonna go to East, and etc. So that allowed us to create a single global namespace that is being used for both East and West, but then again you can have localized data. Well, there are several issues with this. First of all, there is some confusion about what region actually means. Apparently, region is just a container for the zones, so the actual data resides in the zones, and so there's a mix-up here between what is actually, where is the actual data center, for example, for East. Because if you say if the data resides in the East region, you expect it all to be in the East region, but then for disaster recovery, you want to put the secondary zone in West. So saying that the secondary zone for East resides in the West is kind of confusing. So yeah. I think that our first decision and suggestion was to rename regions to zone groups, and hopefully that's going to help avoiding some of the confusion. The second thing is within a single zone group, we don't want to have a single zone where you can write into, because you might have multiple zones that, as we said, like people within a single zone group can be both in the East and the West. We'd want them to be able to write data and read data from their closest cluster, not necessarily to the one that holds it. the one that's designated as the master. So the second issue is to be able to do what we call active to have people or data going to both zones within a single, or to all zones within a single zone group, and then everything's gonna be synchronized between it. Now, how that is gonna be achieved? So at the moment, we have a single master zone that keeps logs for, there are so that we can track it. We have a sync agent that goes through the logs, choose these logs, and then sends commands to the gateways and say, okay, here's this object has changed, go fetch that object. So what we suggest is that each zone is gonna keep its own logs, so that all of the zones could keep track of all of the other zones within this, the same zone group. So the sync agent will then need to be able to go through all the zones within the zone group, and to send the commands to each of the zones, the relevant commands. That's another thing. Now, the backend index log now will need to hold some data about what was the source zone for each entry, because you might have 3 zones. The change originated on zone 1. Zone 2 fetched that change, and zone 3 now takes zone 2's log and see that it has some change. So it needs to know whether it's a change that it needs to apply, or whether it's a change that it has already seen. And so since zone 3 keeps track of both logs of of zone 1 and zone 2, it needs to know whether the change applies, originated in 1 or in 2, and what was the ID for that change. So that's another thing. Another issue is what to do with changes that occurred on the same object on different zones. And here we need to have some kind of a tiebreaker. Since objects that are written are immutable, basically we don't have an issue where you'd have one object that contains part of data that was written in object 1 in zone 1, and part of that was written in another zone. What we're gonna have is one of them's gonna need to win, and we can probably apply a basic scheme in which we say, okay, let's look at the timestamps of the change, and whoever wrote class is gonna be the winner. Now here we can have some issue what happens if the timestamp is equals, but the zone is actually like the change is different. So we need to identify, first of all, that the object is actually different, and then also have another tiebreaker, and it can probably decide, okay, zone 1 always wins, or comparison zone names, and one of them is going to win. But that's really an edge case. That's the second thing. Let's see.
Damon, sorry, one quick question. You could on the you said you have to make sure you identify which zone the change originated from.
Yeah.
Is that just a matter of like tagging each item in the log with some unique identifier for the Rados gateway for the zone and maybe the gateway that created
Yes,
it?
exactly. Yeah,
Deciding.
when we apply a change, we need to say, okay, that's the tag that you're gonna use for this.
Okay.
And also, we need to make sure that objects on both zones are going to get the same tag if it's a copy of the same object. I'm not sure if that's the case at this moment.
Okay.
So that we can identify whether they wrote the same object or it's a different one.
Okay. And in the case of if you have like a put in one zone and then you have a delete of the same object in another zone.
Well, you have the timestamp of the delete.
Yeah.
So,
but which makes sense if you look at the put, say it was
yeah, the put might.
If you do a put, a delete, and a put, say.
Right.
No, it's okay. I mean, if you look at the put and then you look at the delete and you like say, oh, that delete is old, then you can ignore it. But if you look at the delete first and you delete the object, you've forgotten. You no longer have that state about what the version is, and then you look at the put, you're like, oh, that object doesn't exist. So we have to have like some sort of window or something where we remember recent deletes.
Yeah.
That makes sense.
That's a good point. The question is how
big to make it. Yeah, I mean on the OSDs and the PG logs we have like this window of 1,000 operations or whatever where we keep track of those old request IDs, and that's how we make things like item put and like that. But we don't really. Maybe the gateways just have to look at the log of recent. Also, just have a window in the log or something of the last so many requests or something.
Right.
It's a little bit off. I guess in Swift there's like a tombstone. Even when you delete an object, there's a tombstone that's recorded forever. Is that true?
Don't know, but in object versioning we have
something like
in
it.
certain cases we have a delete marker, but I don't think we should be doing that.
Or record a tombstone for some defined window at least. I don't know. Yeah, okay. It might not be the most important part, but we'll have to deal with it at some point.
So we have this issue. Now there's another question about how to handle object versioning. What do you do with the thing with object versioning is that we need to keep some kind of ordering. So in the current scheme, you have some kind of for each object that you manage, there is an epoch that is monotonically increasing. So let's say you write an object, it gets epoch 2, then you write it again, epoch 3, you write again, epoch 4. But what happens if you write it on 2 different zones? So you have epoch 2 that they share, but then epoch 3, each one has different version of that. And then you need to keep the object versions in order from being able to list them from the newer to the older, from the newest to the oldest, which is okay if you're doing it on a single zone. But if you have multiple zones and you'll actually need to be able to list them, not by the epoch, but by some kind of a timestamp. So the idea here is to replace the current epoch scheme with something that is both a counter and a timestamp, so that they'll will preserve the ordering. It'll always monotonically increase, but on the other hand, we'll be able to merge different zones into a single coherent view. And again, we have the issue of what to do with changes that happened on the same timestamp, and here I think the fix would be to again to add to the epoch some kind of a unique string per zone, so that they're not gonna get the same epoch, and one is always gonna win if they happen at the same time, which is probably a rare event. Think
There's a question in chat from Abhishek whether a zone sync could be turned on conditionally for a user request. I assume that's it. I think it's
not at the
right.
not at the moment. Well, it's definitely in Swift. There's you turn it on for specific buckets, and currently what we have is you do it for the entire zone for all the buckets. We can, and we discussed it in the past, we might wanna have some kind of a configuration where we can turn it on only on specific buckets and not on all data, because it makes sense in some configurations.
Yeah.
That's mostly work for the sync agent, not quite gateway specific issue.
Yeah.
Wait, I do want to bring up the changes that would be needed by the sync agent, and you know, maybe we'd need to do some kind of a bigger rework to make it easier for us to implement all that stuff. The sync agent will need to be able to, as I said earlier, to follow multiple zones and not a single zone, and potentially we'll be able to set it up so that it does work for multiple zones, so that you don't need to set up, like if you have 5 zones, to set up 5 different sync agents. So you just specify, okay, you handle these zones, and it's gonna do it all its magic. Another thing with sync agent, probably at the moment, getting to do failover to different zones is not the most trivial job, to put it lightly. I think having active will solve that issue, because essentially you're having complete failover situation, or the scenario that we're talking about doesn't need a specific failover handling, because it's basically syncing all the time. So that would probably solve it, and I'm not sure if fixing the current sync agent to do failover easily, or just doing the active work. What would be the best way to go?
I mean, it seems to me like the place where failover is usually hard is when you have to sort of roll back the stuff that didn't get sent over to their side when you rolled forward. But in an eventually consistent world, that's sort of a non-issue. You just pick the newest thing.
Right.
So it seems to me like just making active just work would just be the synchronize, make it go, and it would just work.
Right, but the question is what to do. Sorry?
If I understand right, then in the case of, say you're actually running it in sort of a active passive type of mode, master-slave mode where all the writes are going to one side and the other side is just replicating. That just means that the logs on the site B are basically in that zone are basically empty. And if you cut over and you have to fail, then those logs will start to get populated.
Right.
And when the master site comes back up, it just will read just those short logs that have only the writes that happened since. Yeah, I mean, yeah, it seems like it would.
Yeah, but you need to set what happens if you do it multiple times, and then you need to set the markers correctly, because and you also need to know whether there's data. It might have been so that data on the original master has been written, but you override it with older data from the site it's switched into, because when they were switched, it wasn't wasn't done atomically.
That's sort of that's the reality of eventually consistent, though. Like you might read something stale and rewrite it. What happens for the like the metadata though, like the bucket, and like you can do sort of the last writer wins simple view of things from the actual object point of view, but on the metadata thing, users are updating ACLs or something.
Metadata wise, I don't think we need to change the current scheme. Metadata wise, it's probably at this point doesn't make sense to have multiple writers.
Yeah. Okay, so Abhishek asks, what about bucket names uniqueness when two different zones try to create the same bucket name? In this case,
it's not a problem because they all go through the same zone. Yeah.
Yeah. There's a master zone that does those operations.
Yeah, and if everything is forwarded to the master zone.
So this is a case actually where you do need a defined resynchronized failover type thing, because if you are doing that on the master zone, you create buckets that haven't been replicated yet, and then the master fails and you fail over to the tail zone, a different user could create the same bucket, and you have to have a clear rollback of some sort.
Yes, for metadata, there still is that issue. Yeah.
Okay.
Yeah, but that doesn't change anything like from our current scheme, so that's where we are at this point.
Yeah. We don't handle that yet, though, right?
Nope.
No. Okay. You're planning to go look at the master log at everything that happened since that didn't get replicated and roll back those items.
Yeah.
Or roll forward, or do some careful roll forward, or reapply or something.
Yeah. What we need to do is, when switching to another zone, is take the current state of the zone that's about to be promoted, keep it aside, then turn off everything, switch, turn on, and now you're good to go. But then if you want to switch back, you need to stop everything and apply the changes. The second question here is, if the above case both users have got success return codes, who will end up losing their buckets? The answer is they're not going to both to get the success return codes, as everything for metadata wise goes to the same through the same zone, and so they're not going to be so only one of them is going to win.
One question?
Yes.
If you use timestamps, what will be the source for the time? From where is it coming?
The source of time is time. Is it a
RAS gateway, or is it a client, or?
It's a gateway.
Was it a? Yeah, so if you have multiple gateways and have to decide which write was the first one, how do you? Is there any way to sync the time between the gateways?
We can
if you have
actually.
multiple gateways, I mean,
We
how
can
do you
actually.
do? There's a problem. Yeah.
We can actually make some kind of time notification between the gateways if we think that's an issue, a big issue, and make sure.
Yeah, I guess it is an issue. I would guess it is an issue because, for example, if you run these in VMs, timekeeping is always a problem. And for the monitors we have, well, for the rest of the cluster we have some notification that the time differs too much, but I guess we need something like that then in the gateway.
Yeah, we can notify if the time drifts goes too big. So gateways send messages to each other. They can think of a scheme where they say they notify that what's the current timestamp, and everyone checks. And if there is some kind of a big drift, then they send some kind of a warning. Now the question is, you need to look at what is the use case for that. Whether multiple writers write to the same object in the same bucket, whether there's any scenario. I'm having I assume it's an issue and it's a problem, but it's not it's not the most acute issue.
Okay.
Because when you have multiple users writing to the same object, only one is going to win. So whether user A or user B. Now, if the time drift is really big, then it's a problem, but it's a problem with other things as well. Start with the time that's reported about the creation of the buckets. But if using the S3 RESTful interface, you cannot drift more than 15 minutes because users would not be able to sign anything because so 15 minutes is gonna be, or 15 times 2, 30 minutes is gonna be the largest time drift, which is huge, but not gonna be days.
Okay.
Okay. Any other questions? Yeah, see, in the above. Okay, so this will take more time than other operations since it uses one link. I'm not sure what it referred to. BH Prinath? Oh, yeah, so bucket creation, it already happens, right? Bucket creation on a zone that is not the master is doing just that. It goes through a WAN, creating the bucket on the on the master, going back. Bucket creation by large is not an operation that happens. Usually, it's not part of the I/O path, or not supposed to be, at least. It's so some latency there might.
The leader has muted your line. To unmute your line, press #6.
Yeah, I'm not muted. So So that might be acceptable. We can think of some other schemes where we have different, at a higher level, we have different settings in which we have different master zones for different tenants or something like that. So we can say, okay, this tenant is a west tenant, and all the buckets that create here is gonna go through the west, and here that's an east tenant, but that's gonna go into a higher at a higher level configuration. So if you create different setups, and one setup's gonna be centered around west, and another setup gonna be centered around east. That's about it.
Okay. All right, so I don't see any more questions. So I think we're pretty much set with this one, and we can move on.